Apply the law of conservation of energy. Because the copper and water are placed inside an insulated cup, we can assume a closed thermodynamic system where no heat is lost to or gained from the surroundings. Therefore, the magnitude of heat lost by the hotter copper cube must equal the magnitude of heat gained by the cooler water when they reach thermal equilibrium. Q copper equals Q water. Relate heat transfer to temperature change. The heat transferred, Q, is determined by the calorimetry formula. Q equals mc delta T, where m is the mass of the substance, c is the specific heat capacity, and delta T is the change in temperature. Set up the mathematical equality. Equating the magnitude of heat exchange for both substances yields mcu times ccu times delta Tcu equals mH2O times CH2O times delta TH2O. Simplify the equation using the given values. The mass of both samples is identical, 10 g. Substituting this and the given specific heat capacities into the equation. 10 g times 0.385 j slash g times degrees C times delta Tcu equals 10 g times 4.18 j slash g times degrees C times delta TH2O. Since the masses are equal, they cancel out, simplifying the relationship to 0.385 times delta Tcu equals 4.18 times delta TH2O. Compare the magnitude of temperature changes, rearranging the simplified equation to find the ratio of the temperature changes. Delta Tcu over delta TH2O equals 4.18 over 0.385, approximately 10.9. This mathematical relationship shows that the temperature change of the copper, delta Tcu, is approximately 11 times greater than the temperature change of the water, delta TH2O. Identify the core concept. Water has an exceptionally high specific heat capacity compared to metals like copper. This means water requires far more energy to change its temperature by 1 degree Celsius than copper does. Under conditions of equal mass and equal heat exchange, the substance with the lower specific heat capacity, copper, experiences a much larger temperature change, confirming option A is correct. The correct answer is option A. The temperature of the copper changed more than the temperature of the water.